Okay, so let's move on to significance. Okay, so many times we do tests. When we do inferential statistics, that means we are inferring and we're going to do a test. And what we're looking for, again, going back to probability, and a key variable is the variation. What we're looking for is the probability that the variation in one sample can be attributed to chance. And we typically do that in statistics with two ways. We can either do it with a p-value or we can do it with confidence intervals. And as you'll see, I believe in the next slide, it's really measuring the exact same thing. It's just two different techniques. It's common to use a statistical significance of 0.05. That means 5%. Okay, what that would mean is that the difference between these two means, if it's less than 0.05, that means there's less than a 5% chance that the variability or that the difference between these two samples was due to chance. Okay, so again, it's going back to those probability calculations, but applying some good math to it. The 0.05 is standard, but it's not absolute. Depending on the type of research that you do, you may want to have a lower percentage if you're doing, maybe testing, maybe a medication. If you're doing something that's more of a social thing, you may not be able to get to 5%. It varies. It could be as high as say 10%, sometimes as low as 1%, but the common one would be 5%. 0.05. So what we're looking here, so we have our two bell-shaped curves with normal distributions, and what these represent are two means. So let's say, for example, we're calculating the change in blood pressure. So I have the curve on actually the curve on the right is the pre-blood pressure, and then I'm going to do a low sodium intervention. And so I want those blood pressures to be lower, so that I'm shifting the curve a little bit to the left. So if I'm using a p-value and doing, say, for example, a t-test, in this case I would use a t-test. I'd use a paired sample t-test. We'll talk about that more in the next webinar. So I'm going to measure the probability that these two samples could be different, just simply due to chance. Again, if I do a sample of blood pressures and then I retest blood pressures in 8 weeks, I'm not going to have exactly the same blood pressures. I'm going to have some variability. So I want to know, was there a statistically significant difference between those two? So let's look at now we have another curve. It's the same thing, but now there's a larger spread between the two, okay? So whether we're doing p-values or confidence intervals, what we're looking for is the overlap between these two. So take a look here. I don't have any legends, but if you can just imagine these two bell-shaped curves, look at the amount of area that includes both of the curves. The part right in the middle, it almost looks like a diamond shape. That means there's a lot of overlap in these two, and it's probably very likely that there isn't a statistically significant difference, okay? As opposed to this one where if you look, there's quite a bit of a difference here. There is still some overlap, okay? It's a no-brainer if there's no overlap at all, okay? But the way you calculate the significance then is to either have a p-value, so you'll have a calculated p-value, or you'll have confidence intervals. So I want to explain how that works here as well. If you have confidence intervals of two groups, so typically it's a 95% confidence interval, it could be a 90, it could be a 99. If you have a 95% confidence interval and there's no overlap between the two intervals, and that would be the case in this one. If I actually drew the 95% here, there would be no overlap. So I would have a statistically significant difference. The other way you can look at confidence intervals is if you're looking at a change score. So you're looking at a delta, for example. What you're looking at are both the lower, and so if, again, I'm using my blood pressure as an example. So let's say my blood pressure was lowered by an average of 5 millimeters of mercury, okay? And I did a p-value for that. The other way I could look at that p-value is my 95% confidence interval. And my range is that it was reduced by, let's say, 1.3 to 7.6. So what you're looking for is 0 included in the interval? If 0 is in the confidence interval, then there is not a statistically significant difference. And the way you would tell that, obviously with 0, is the lower number would be a negative number, the upper number is a positive number. So when you're looking at a change score and a confidence interval, a negative number to a positive number, no significant difference. If you have 2 negative numbers or 2 positive numbers, then you do have a statistically significant difference. Research.